All right, everybody, welcome to Earth Science. Second part of the review sheet. Again, should be a fairly easy one. And this diagram may remind you of seasons. I won't put any specific seasons questions on there, but the angle of the sun has a big thing with this unit because the principle is the higher the angle, the more directly overhead is, the hotter it's going to be. So maybe, and again, we don't have to write a million notes on this thing, but we'll say it's hot right here. That's the most intense possible incoming solar radiation, insolation, is when it's directly overhead. So on this season, and again, don't worry about seasons, but this would be our summer, Northern Hemisphere, the most direct insolation is going to be at the Tropic of Cancer. As that angle gets lower, and lower and lower, the energy gets more spread out per unit area. I think we did a thing with like a flashlight shining straight down versus one shining at an angle. So whatever that angle is, it either more efficiently at a high angle gives you energy or less efficiently at a low angle. So this little diagram right here kind of shows us that if we've got this incoming solar radiation, if it's directly overhead, that's going to be your hottest. And they did it by showing us palm trees. But take that same exact amount of energy, 1 unit between them, and that's just an arbitrarily made up kind of thing, but 1 unit translates to 1 unit here, whereas 1 unit then at that angle gets spread out, which leads to a more kind of temperate climate. This looks like upstate New York. Or put it at a really low angle, and the energy is going to be really spread out, meaning there's less to go around, right? If this is like some amount of money split between one person, they get all that money. If this is some amount of money split between multiple people, they each get less money. You're taking the same amount of energy but spreading it over a larger area. Therefore, it's not going to build up as much heat, right? So if you see that in context of the globe here, let's just do it near the equinoxes because it's easiest to look at. Near the equinoxes, the equator would be getting the most, whereas up near the poles gets it at this low angle. So the energy gets spread out and it's not as intense, not as bright. I'd guess maybe one-ish question on that. We'll see. Let's also throw in there, excuse me, while we have a moment, and I think people did a great job with this. I'm not really concerned about either of these two things. I think they'll go well when we have that question, inevitably. Dark colors heat up faster than light colors. And you all did that black versus shiny can experiment. And even if you haven't finished that lab yet, I think that you saw it. I think you saw how it works. Textures may be a slight bit trickier. If something is smooth, it has less surface area than something that's rough. Let me blow this up a little bit. So a smooth surface has less available spots to grab energy. So something that's rough will more efficiently grab energy. So asphalt's a pretty good example of something that's both dark and rough. It's got lots of little nooks and crannies to grab sunlight. So it's a very efficient absorber of energy. So, I mean, it's all on here already. Rough surfaces heat faster. That'll be that because of surface area. Let's really quick, as part of this one, throw in the 3 forms of energy transfer. This is another thing that I'm thinking we're pretty comfortable with at this point, but which means I won't go into it in great detail. But energy that is from coals of fire, or if you've got a wood stove like over there, and it's emanating heat, that is radiation. If you've got the flow of a fluid, like the water in the pot, or this would be happening in the gases above, in the atmosphere above the fire. If you've seen fire, like the sparks and the ash bits in the air, rising up quickly over the fire, that part, the swirling gases part, isn't radiation. That part is convection, which is really what the story of meteorology is going to be, is that since on a large scale air is moving and doing these convection cells, that brings with it the weather that we get. Whereas B, as it travels down the metal pan, down the handle, molecule to molecule contact, energy transfer through touching, that is conduction. So we did the lab with the metal bar connecting the 2 cups for conduction. We did the 3 labs with the light bulb for radiation, and I don't really have a good one for convection. But again, I'm pretty comfortable with those so far. From what I've been able to gather, I think people are doing pretty good, and it won't be much more than just identifying them. I think it'll be in good shape. All right, that's that. Getting there. Keep it up, folks.